In this video, I'm going to talk 4.5 from the book, okay? Chapter 4, section 5, which is the last section from the book. It is integration by substitution method, okay? So far, we learned some of the formula for the antiderivative or the integration, right? For example, we learned x to the n. The antiderivative is x to the n plus 1 over n plus 1 plus c. Cosine x dx is sine x plus c, and so many other formula that we learned, right? By using the inverse or the reverse process of the derivative. Now we will do some more, we will study some more method or the techniques or the formula of the antiderivative. For example, none of the formula will help you to do this integration, because you see that there is the product. You see that? It is x squared plus 1 to the 1/2 times 2x. If it was just 2 instead of 1/2, you would FOIL that, right? You would write x squared plus 1 and then parenthesis and then another parenthesis x squared plus 1, and then you would FOIL, and then finally you would multiply with 2x and then you would integrate. But there is 1/2, which is the root, so you cannot FOIL this easily, right? So how do I do this type of integration? Okay, so the substitution method is a very, very useful and important techniques, and very simple, very basic, and very important and useful technique to do the integration. Okay, so what is the substitution method? Is usually if the problem has a product or sometimes the quotient. You see that there is a quotient here. There is the quotient here. In that case, what we do is we usually assume that the complicated form. What does that mean? That means 2x is just simple 2x, right? But here you have x squared plus 1 to the 1/2. That is the harder term to integrate, right? Usually, what we do is you take that thing under the inside the parenthesis without the exponent. Just take that as u. What we do is you let x squared plus 1 equals to u. So what we are trying to do is we are trying to change all these x into u's, because see, after you substitute that, what do you get? Let me denote that by I. I is the integral, okay? This integral I denote by I. So I can be written as, since when you replace x squared plus 1 by u, then this will become u to the 1/2, right? So this thing changed to u. Again, when you set u, don't take that 1/2 without the exponent. Just the things inside the parenthesis. Okay, take that as u. Now, how about this 2x and dx? What happens to this 2x and dx? How do I write this in terms of u? That is the next thing. Okay, so what should I do for that is find the derivative on both sides. What do you get? If you find the derivative, then you will get 2x equals to du over dx. You see that? I'm finding the derivative on both sides with respect to x. Now this can be written as, you can think of like this. There is like cross multiplication type of thing. It is basically finding the differential. Okay, so you can write du equals to, do you remember that if y equals to f of x, then what is y prime, or what is dy? Just the differential, right? F prime of x times the dx, right? You can think that way. What is the du here then? So the du is basically 2x dx, right? 2x dx. So for this term, 2x dx, you can just write du. Now you see that this integral is very easy to integrate now. How do you do that? It's basically u to the 1/2 plus 1 over 1/2 plus 1 plus c. You understand? And this is equals to, so u to the 3/2 over 3/2 plus c, right? Because plus c is default in the indefinite integral. What do you mean by indefinite integral? If there is no limits of integration, then you always write plus c at the end, okay? So this can be written as 2/3 u to the 3/2 plus c. This is not the final answer. Why? Because our question was in terms of x. So you need to replace back the value of u. So the final answer will be 2/3. What was our value of u? X squared plus 1 and then 3/2 plus c. This is the final answer. So the idea is the complicated term without the exponent, the complicated term that has some exponent, some fractional exponent, or any other that type of thing, the thing inside the parenthesis, you denote that by u, and then you find out the derivative or find the differential. Okay, so find out the differential. What you get is du equals to the derivative of that and then times dx, and you replace that by u and then that thing by du. Okay, and then you just use the regular integration techniques, but don't forget to plug in back. All right, let us do this example. So how do I do this problem here is, look at this. This is x times, right, 2x squared plus 5 to the 9. You see that? So how do I do this problem? Is again the substitution, because the general these type of rules, it doesn't work. I mean, it is hard to expand that x that thing to the 9, right? Because it is like 2x squared plus 5 and then 2x squared plus 5 times 2x squared plus 5 9 times. You don't want to do that way because it is too complicated, too long, right? So what you do is you substitute u. Okay, so solution. So what should be u then? Let this is the complicated term, right? So I will set this thing equals to u without the exponent, just that thing, base thing as equals to u. Let's say 2x squared plus 5 equals to u. So what we did is we substitute that by u, but what we have is we still have x times dx left. So how do I write that in terms of u is find the differential, right? So what is the derivative of this with respect to x? It is like 4x equals to du over dx, right? So you can write this implies du equals to 4x dx. So what is left here is this is x and then dx, right? We don't need the value of 4x dx. We need the value of x times dx. What is the value of x times dx? Divide by 4 on both sides. You will get, this implies x dx can be written as 1/4 du. You understand that? So here, when you find the derivative, we got exactly what we needed. 2x dx is du, right? But here we needed x times dx, but when you find out the derivative, you got 4x dx is du. So you need to find out the value of x dx because that's what we are needing here. You understand? So x dx equals to 1/4 du. So what I do is, let us denote that by I, the integral. Therefore, the integral I is equals to, so this is u to the 9 times x times dx is basically 1/4 du. You see that? Now this 1/4 is a number, a constant. I can pull that out, 1/4, and integral of u to the 9 and then du, right? Since u and u match, then now you can use the power rule. So it is 1/4 u to the 10 over 10. You understand that? Plus c. So this is not the final answer because you need to plug in back that u value. So it will be 1/40, and then you write 2x squared plus 5 to the 10 plus c. That is the final answer. It is pretty easy method once you know it, right? But you need to, the first thing is what should be u. That is the very important thing, okay? And after you do a couple more examples, you will know what should be u to do this, to do the problem, okay guys? So let us do this. So what do you think? What should be u? What should be u? You're right. So that must be u, right? That is the complicated form that has power. So let's do 4 minus x squared equals to u. Or you can write u equals to 4 minus x squared, right? So that is exactly the same thing, no problem. So what you do is, how could you write that then? So negative 2x dx is equals to what? Du? Because when you find out the derivative, you will get negative 2x equals to du over dx, right? And then I multiply, you can think of like what will be du? Du will be the derivative f prime of x times dx, right? That's what we were using here, okay. But what we need here is we need 7x dx, the value of 7x dx. But we found the value of 2x dx. This is not what we need. We need 7x times dx, right? So how do I do that? I will write x dx equals to negative 1/2 du. What did I do? I divided by negative 2 on both sides. Now I multiply by 7. So 7x dx equals to negative 7/2 du. That's what I got. So the value of 7x dx will be negative 7/2 du, and this is u to the third. Therefore, the integral I assume the whole thing as integral. I denoted that by that. So integral of that, now 7x dx is negative 7/2 du. You understand that? Divide by u to the third. Right? Let me pull that number out. Negative 7/2 and then 1 over u to the cubed and then du. You can write that way, correct? So this is written as negative 7/2. Let me do that thing. And then integral u to the negative 3. This is how I find out the antiderivative, right? Du. So how much is that? This becomes negative 7/2 and then u to the negative 3 plus 1 over negative 3 plus 1 plus c. So how do I write that? This is negative 3 plus 1 is negative 2, right? Negative 2 and then negative 7/2 will be positive 7 over 4 and u to the negative 2, right? So you can write plus c. So you can write this as 7 over 4u squared plus c. You understand that? Now plug in back the value of u. You will get 7 over 4 and then 4 minus x squared to the cubed and then plus, not cubed, square, right? Because u is squared. So this should be square. Okay, let me write that square plus c. That is the final answer. 7 over 4 times 4 minus x squared to the square plus c. So let me talk about this example. Find the solution of this dy over dx equals to that. So this is called differential equation. Why is that? Because this has a derivative. If an equation has a derivative, then we call that as differential equation. So how do I find out the solution? Solution of a differential equation is the value of y. The derivative is given, you want to find out the value of y. How do I find? You integrate on both sides, right? So when you integrate, you will get y equals to, you get integral of 18 minus 9x squared over under the root x cubed minus 6x plus 4. And there is dx. When you integrate, that's what you get. Okay? Now what should be u? Tell me. You're right. That thing under the root must be u. Let's say let x cubed minus 6x plus 4 equals to u. So I set that as u. Now what happens to this term and dx? Let's find out the derivative. Then the derivative is 3x squared minus 6 dx. You see that? Equals to du. I find out the differential of u, right? So that will be du is f, this, the derivative of that times dx. Now what do I need here? I need 18 minus 9x squared. But what I got here? 3x squared minus 6. What should I do here to get 18 minus 9x squared? So I need to multiply both sides by what? I need to multiply both sides by times negative 3, right? Times negative 3. If I do that, what do I get is negative 9x squared plus 18x and then times dx, right? Will be negative 3 du. You see that? So instead of that quantity on the top, the whole with dx, you can add negative 3 du. So this can be written as, let's do that. This can be written as y is equals to, I would write this as y is equals to, let me write that integral is negative 3 du for the whole thing, right? And in the denominator there is root under u. So how do I write that? Let me pull that negative 3 out and then let me move that to the top, u to the negative 1/2. You see that? Because root u is u to the 1/2 and then du. So what happens to this? Just find out the integral. Negative 3 u to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c, right? So what do you get? Negative 3 and this will be 1/2, right? This quantity is 1/2. So that is positive 1/2, but it is in the denominator, so this will, if you write the times reciprocal, that will be negative 6, and then u to the positive 1/2, right? That's what you get. So plus c is there. So now plug in the value of u. What is our u? U is that quantity, right? That is the u. So let me plug in that negative 6, and then write down that. You can write in the root form because that is the square root. 1/2 is the square root. So x to the cubed minus 6x plus 4, right? And then that is that, and then root is the 1/2 is root is for 1/2. By the way, this root is like this. So this is not the 6th root, okay? So this is 6 times that thing. So and then plus c. This is what you get as the final answer for this problem. Okay, let us see some more examples, okay? So on this example, I want you to find out the integral of sine 5x dx, okay? So how do I find out this? Is what you do is, what should be u again? We know that what is the integral of sine x only, but there is, if there is some number times x, we don't know that formula yet, right? So what do I do is, I want to set that as u, okay? So set, so u equals to 5x. So now you find out the derivative, you will get du over dx equals to 5, right? This implies du equals to 5 dx, right? So but we need to find out, so this will be like sine u and then we need to find out the value of dx. So what is dx? Dx is 1/5, so divide by 5 on both sides. So you'll get dx equals to 1/5 du. That's what you get, right? Now let us plug in into the integral. So the I is the integral equals to sine u times dx is 1/5 du. You see that? So you pull that 1/5 out, 1/5, and then integral of sine u du. What is the integral of sine? So negative cosine, right? Because the derivative of negative cosine is positive sine. So 1/5, and then you do negative cosine of u plus c. You see that? So what is the final answer then? It will be 1/5 and then minus 1/5, right? Negative 1/5 cosine of 5x. I plug in back the value of u and then plus c. That is the final answer. How about this one? What should be u? So here I am taking u equals to 1/theta because that we don't know what is the integral of cosine 1/theta, right? That's why I'm setting that as u. So set 1/theta equals to u. Now find out the derivative. What is the derivative of 1/theta? You do theta to the -1 equals to u, right? Now find out the derivative. You will get -1 theta to the -2 equals to du over d theta. I'm finding with respect to theta, not with respect to x, because there is theta there. So what you get is, this implies -1/theta square times d theta equals to du. You see that? But what do I need? I need 1/theta square and d theta. So I don't need that negative sign. So I divide by -1 or multiply by -1. So what do I get is, therefore 1/theta square d theta can be written as -du. You see that? So it will be like cosine u, and then that thing will be -du. So I'm assuming the whole thing as integral I is equals to integral of cosine u times and then -du. That will be negative integral of cosine of u du. What is the integral of cosine u? It is, there is minus sign already, so negative sign, so sine u, right? Because the derivative of sine u is cosine u, and then plus c. Now plug in the value of u, negative sine and 1/theta. You see that? And then plus c. That's what it looks like. So let us do some more examples on the integration by substitution. Okay, so can you guess what should be substituted as u? Is that secant or the tangent? I would say tangent. Why is that? Because the tangent is inside the root. You see that? So let's do tangent 5x equals to u. Let's say u equals to tangent 5x, right? Now we need to find out the du, right? So what will be du? Du will be this derivative of that and then times dx, right? What this is like tangent u kind of. Do you remember the chain rule? It is like tangent u. So what will be the derivative? It will be like when you do the du is secant square, u is 5x, right? You can say, and then times that 5, right? And then there is dx. So it is f prime times dx, that is dy, right? It's like that. So u equals to tangent 5x. So du is secant square 5x times 5 and then dx, right? So but what do I need is I will need the value of secant square 5x times dx only, because this will be u. This I want to write this in terms of u as well. So this 5 is extra. So I want to divide by 5. So what do I get is what this implies 1/5 du is equals to secant squared 5x times dx. You see that? So this is the value of secant squared 5x times dx is 1/5 du, and this will be u to the root 7th root of u, right? So that will be, therefore let's write down I, the whole integral I denote by I, is equals to, I would write 7th root of u and then times 1/5 du, right? This can be written as 1/5. I can write outside, so it is u to the 1/7 and then du. You see that? So 1/5. What is the integral of u to the 1/7? U to the 1/7 plus 1/1/7 plus 1, right? So this can be written as, this is equals to 1/5 u to the, so 8/7, right? Because there is like, this is 1/7, this is 7/7. So 7 plus 1, 8/7 over 8/7. Now plus c, right? I should not forget that constant of integration as a c. So how do I write this? This is like 1/5 times, you need to write the reciprocal of that, 7/8, and then u to the 8/7 plus c. So the final answer is, 7/8 times 5 is 40. And what is the value of u? U is tangent 5x, right? Tangent 8/7 and then 5x plus c. That is the final answer. Okay? So let's do this problem. So what should be u? You're right, that should be u, because that is under the root, right? So which is harder to integrate, you can think that way. So this one is easy term. There is no root, there is no exponent, but this has exponent as 1/2. So we'll take that as u. So let 7 minus x equals to u, right? Find out the derivative. You will get -1 equals to du over dx, similar to the other problem, right? So what will be du then? So you will write du equals to -dx, right? So, but we need to find out the value of positive dx. You see that? Positive dx. What is the value of positive dx? Is -du. -du will be positive dx, right? I multiply both sides by 1, -1. So see here, this thing will change to u. This will be -du. How about that one? So how do I get that? So far we didn't have this type of problem because there was nothing left. After you said u and du, there was nothing left. But there is x plus 1. So we will have to find out from here, okay? So what I want to do is I want to add x and subtract u. Subtract u. What do I get? I get 7 minus u, because that and that cancel out, that and that cancel out, equals to x, right? So what will be x plus 1? Let's add 1 on both sides. Plus 1 plus 1. Why? Because there is x plus 1 we need to find out, right? So 7 plus 1 is 8 minus u equals to x plus 1. So instead of x plus 1, I can write 8 minus u. This is u. This is -du. Hence, what you can write is, let me write that. So this can be written as, so let's write down I. Let me take this whole thing denoted by I is equals to, this is 8 minus u. You see that? And then root under u is still there, and then times -du. You see that? Let me pull that negative outside. So let me write it here. So I equals to negative, and then 8 minus u and u to the 1/2. You see that? And then du. How do I do this? I need to distribute this to both 8 and u, right? So negative 8u to the 1/2 du, and then minus, oh, that will be plus, right? Because this is like negative times negative is positive, right? You can write that as positive. And then integral u times u to the 1/2 will be u to the 1 plus 1/2. That is 3/2, right? Du. You see that? Now let me write here. This is equals to negative 8 integral of u to the 1/2 du plus integral of u to the 3/2 du. I haven't done integration 8, right? Now I'm going to do that. Negative 8. What is the integral of u to the 1/2? It is u to the 1/2 plus 1. U to the 3/2, right? 1/2 plus 1 over 3/2 plus, what is the integral of u to the 3/2? It will be 3/2 plus 1, right? So u to the 5/2 over 5/2 plus c. So what is the final answer? The final answer is written by replacing back the value of u, okay? So that will be 8, and then it will be times 2/3, right? So it will be 16 over negative 16 over 3, and then 7 minus x to the 3/2, that is the value of u, and then plus, this is 2/5, and then 7 minus x to the 5/2, and then plus c is the final answer. You see that? And the last example I'm going to do here is, you have a definite integral, you have a limit as well. So we do exactly the same process we did here. We said u equals to something and then do the integration, get the final answer. After you get the final answer like this or like that, what you do is you plug in the value of, you do vertical line and then do 0 and 1 and you plug in the values, okay? So let us do this example. So what should I set? Let us consider just 0 to 1 without 0 to 1, without that first, and then we will plug in at the end, okay? So solution, we want to find out just x cubed and then 2x to the 4 plus 1 to the square dx. I want to find out just that one first, and at the end, after I find out the answer, I'll plug in the limits there, okay? So set u equals to, what should be u? U is that thing, right? The base, that base without the exponent. So 2x to the 4 plus 1, okay? So what will be du then? This implies du will be, what is the derivative of that? 8x cubed and then dx, right? Because that will be du over dx, and then I multiply by dx. You can think of that way, but it is basically the, so if y equals to f of x, then dy will be f prime of x and then times dx, right? That's what I'm doing here. So this will, so basically this quantity is u, right? This quantity is basically u. This is u. So x cubed times dx. What will be x cubed times dx then? So that will be multiply by, divide by 8, right? So divide by 8, you get 1 over 8 du equals to x cubed times dx. That's what left. You see that? So here, what is the integral? Let's say this is I. So the integral I is equals to, I can write u to the square, because that was u to the square, and x cubed times dx is 1 over 8 du, right? So I can pull that 1 over 8 out, and then I got u squared du. You see that? And this can be written as 1 over 8, and u squared is u to the 3 over 3 plus c, right? So this is what you get. Now what we do is you plug in back the values of u. You get 1 over 24, and then u is 2x to the 4 plus 1 to the third, u3 plus c. That's what you get. Now, but we need to find out for 0 and 1, right? Therefore, integral of 0 to 1 x cubed, integral of x cubed times 2x to the 4 and then plus 1 to the square dx is equals to, basically what we write is 1 over 24 and then 2x to the 4 plus 1 to the cubed plus c, and then there is that limit of integration, right? What is the limit of integration? You plug in 1 and then do minus and then you plug in 0. That's what you do, right? So what do you get is I would get 1 over 24 2 times 1, because 1 to the 4 is 1, right? And then plus 1 to the cubed plus c. I plug in 1 and then I would do minus. I'll plug in 0. 1 over 24 and then 2 times 0 plus 1 to the 3 plus c. That's what I get, right? I plug in 1 for all the x's and write non-x term as it is, right? And then I do, and then minus, and then write down, plug in 0 for all those terms, wherever x. And then if there is no x there, you just copy that, okay? So what you get here is 1 over 24, 2 times 1 is 2 plus 1 is 3 to the 3 is 27. You see that? Plus c minus, how much is that? 1 over 24, 2 times 0 is 0 plus 1 is 1 to the third is how much? 1, right? So 1 over 24 and then minus times plus is minus c. You see that? The c and c cancel out. And this is true for all the definite integral. If there is a definite integral, you don't have to write down that c because it will cancel out anyway, okay? So how much you got is 27 over 24. 27 over 24 minus 1 over 24 is basically 26 over 24. That is basically, so 26 divided by 2, you will get 13 over 12 is the final answer. 13 over 12 is the final answer. Alright guys, thank you.